When I'm trying to understand something complicated like parabolas, it helps me to break it down into something simpler like lines. With lines, you only have to deal with a slope and a y-intercept, but parabolas have an A and a B and a C. The shape is more complicated. There's a vertex you need to keep track of. It's a lot. So lines are kind of like letters if parabolas are words. Lines are like atoms if parabolas are molecules. You can break parabolas down into lines, and hopefully, if you're good at lines, you can use that to your advantage. So let's see a line first of all. This line's pretty standard, just a slope and a y-intercept that I can mess with. For example, if I change this y-intercept, it moves the line up and down. And if I change the slope, it just changes the steepness of the line. You know, basic lines, all that stuff that you're used to. Let me see if I can get this back on nice even numbers. And I also have a point indicated here. Not the y-intercept, I'm interested in the x-intercept. That point right there. And I've got it adjustable, so I can move this line around by dragging the x-intercept. Okay, I'm going to need a second line for this. And there we go. 2 lines. Okay, if we take these 2 lines and multiply them together, something interesting is going to happen. First, look down here. Negative, negative. Both lines are negative all the way on the left. Negative times negative is positive. So that means if we multiply these, our answer will be positive up here. Another way to get positive is positive times positive, which is happening all the way on the right. So on either side, we should be positive and positive. But right here, it's 0. And 0 times anything is 0. Between these 2 zeros, one of the lines is positive, the other one is negative, which means, starting from left and going to the right, negative times negative equals positive, and then 0, and then positive times negative equals negative, and then 0, and then positive times positive equals positive. It's going to go from positive down to 0, down to negative, back up to 0, and then up through the positives again. Let's see what that looks like. Okay, there's a shape that does exactly what I just described. It starts off positive, comes down through 0, then it's negative for a little while, then comes back up to 0, and then it's positive for a while. And what's cool is, if I drag these lines around, you'll see that the x-intercepts of the lines follow the x-intercepts of the parabola. In fact, I can move this line past the other one, and it doesn't matter. They just change places, who's on the left and who's on the right. Now, this isn't quite complicated enough for me to make this parabola flip upside down. To make that happen, I would need to change one of the slopes to negative. So let me go ahead and do that. If I make this slope negative, what I'm doing is I'm changing when the line is positive and when the line is negative. I can still move the x-intercept around and it should still follow it. But the point is, the x-intercepts of the parabola come from the x-intercepts of the line. And what you can do is construct this parabola out of those lines simply by multiplying them together. This ties neatly into another property of parabolas, and that has to do with the slopes of small sections of it. You probably have already learned how to calculate the slope between 2 points in a previous unit on lines. So I've got here a parabola with points marked out on it at even intervals of x. For example, this point over here is at -4, 5, and you go 1 to the right, -3, 0. What is the slope of the line that connects those 2 points? Well, it goes over 1 to the right and down by 5, so that's a slope of -5. Let's move on to the next little segment. From -3, 0 down to -2, -3. Again, it goes over 1 to the right, but this time it goes down by 3. We went from -5 to -3. The next little segment, this goes from -2, -3 to -1, -4. Again, over by 1, but this time only down by 1. We went 5 and then 3 and then 1. Those numbers sound familiar? Okay, let's keep going on. -1, -4 is the vertex, which means it's just about to turn around. The next pair of points, -1, -4, and 0, -3, again, 1 to the right, but then up by 1. The slope just became positive, and that should be obvious just looking at the graph that the slope is positive now, but it went from -1 to +1. Isn't that odd? Okay, next points here, 0, -3, and then 1, 0. 1 to the right, 3 up. So we went 5 down, 3 down, 1 down, and now 1 up, 3 up. What do you think comes next? This next segment, this last segment actually, goes from 1, 0 to 2, 5. That's right, it went over 1 and up by 5. 5, 3, 1 down, 1, 3, 5 up. Those are the slopes of even increments of a parabola. If you were to show those lines and then graph those slopes at the x values where they occur, they line up like this. That is, the slope of a parabola isn't constant, it's always changing. But the change itself is linear. That is, if you take all the slopes of a parabola and graph them where they happen, you get a line of slopes. A parabola is not a line. You can make it from lines, and it still has lines in its DNA, so to speak. If you're good at lines, you can handle parabolas.